Hey, welcome back. I want to continue with this problem. There was more to B than I gave it credit here. This is where I finished. Let's see, what number was this? This was chapter 37, number 34. And let me just kind of read it real quick here, but this is, or explain it. This is the one with the block going back and forth. And part B said if the maximum sound level heard by the person is 60 dBs, and that's where the problem cut off. And I just kind of assumed it said what is the intensity, so I did that. But after I made that video, then I realized that there was a little more to the question when I turned the page in the book. So it says it's 60 dBs when he is closest to the speaker, which is 1 meter away. Okay, so the number I solved for right here, this is the intensity when you're 1 meter away. The question goes on to say, what is the minimum sound level heard? So to kind of redraw this picture, here's the wall, and when it is stretched the furthest, that's when the observer is going to hear the loudest sound or the highest sound level, and it's 1 meter away. The minimum sound level is when this speaker moves back to maybe this position in our drawing, which, remember, it has an amplitude of a half a meter. So it would move back a half a meter to equilibrium and then another half a meter, so that's another meter away. So it's a little further. In fact, it's twice as far at this point. And that's why the sound level and the intensity is going to go down. So what I solved for was the intensity at this point, 1 meter away. The thing that makes the connection to this problem is the conservation of energy. So let me take this one step further and remind you that intensity is power divided by area. So we can learn how much power is coming out of this speaker by taking this intensity, which was 10 to the minus 6 watts per square meter, and multiplying it by area to get the total power coming from our speaker. So in our case then, with our sound coming out, and they don't say anything about, how the sound is directed out of the speaker. So I'm going to go with the idea that it's uniform, or isentropic is the fancy word, in every direction. And so it'll be spread out on the surface of a sphere. And the surface area of a sphere is 4 pi r squared. So that's going to give us the answer to how much power is coming out of this speaker. And that's the key to figuring out what the intensity or the sound level is at any other point, because we know the power is going to continue the same amount here. So let me grab a number here. So grabbing my calculator, we already got an intensity of 1 times 10 to the negative 6. So now I can multiply by 4 times pi times, and I'll just go ahead and put it in, 1 squared, which is still 1, which doesn't change anything, but there tells me how much 1.26 times 10 to the negative 5, and this would be watts. So that's the power coming out of the speaker. So now we can continue this problem. So let me flip the page here and say, all right, now that I have this number, I can get the intensity. Intensity is power over area. And so taking the same power, 1.26 times 10 to the negative 5. Let me just double check that number. Okay, good. And then divide that by the area. Now, we're 2 meters away, so this would be a 2 squared. And so, grabbing the calculator again, there's the power. So let me divide by 4, divide by pi, and divide by 2 squared. I'll just put in a 4 if that'll be okay, and hit enter. And so then I'll get 2.5 times 10 to the negative 7. And of course, this is watts per square meter. So there's the intensity. And then finally, I can finish this by saying, okay, so what is the sound level measured on the decibel scale? And so let's take that intensity, divide it by its reference, which is that 10 to the minus 12, right? The smallest amount of intensity a human ear can hear with. And then we'll get our sound level. So there's the intensity. Again, divide by 1 times 10 to the negative 12, all right? Take the log of that number and now multiplied by 10, and the sound level has dropped to, looks like it rounds to 54 dBs, 54 decibels. And so dropped from 60 down to 54 decibels. All right, hope that helped.